The world's biggest rocket that could take humans to Mars in the 2030s is a step closer to reality. NASA has completed a crucial hot-fire test of its RS-25 engine flight controller at Stennis Space Center near St. Louis, Mississippi. A 3D printed shock absorber, intended to give astronauts a smoother ride, was tested during the 365-second event. The part will now be installed on an engine for use by NASA's Space Launch System, SLS, a deep space rocket designed to be the most powerful on the planet. The rocket, set to take its maiden flight in 2019, will eventually carry humans on the Orion spacecraft and enable missions to the Moon and Mars. Over the next year, engineers plan to add additional 3D printed parts to the RS-25 engine to reduce waste and costs associated with the SLS. The full duration test came a month after NASA capped a year of RS-25 testing with a flight controller test in mid-December. We ended 2017 with a successful engine test in December and have now maintained that momentum into 2018, said Dan Adamski, RS-25 program director at Aerojet Rocketdyne, who collaborated with NASA on the test. Future testing this year will continue to add to the program's inventory of flight controllers and will bring additional development hardware into the test program to demonstrate design, manufacturing and affordability improvements. The 3D printed engine component, called a pogo accumulator assembly, is part of an ongoing series of tests on parts made using advanced manufacturing techniques that will make building future engines more affordable. Aerojet Rocketdyne engineers told Fox News that the shock absorber component was printed using a laser and metal powder, with a machine that builds the part in two halves in weeks, compared to hand construction which can take years. As you're driving along a cobblestone road, you have dampeners in your car that make it a nice smooth ride, and that's what we're doing for astronauts, said Alan Fung, one of the lead mechanical design engineers on the project. When the astronauts are riding up into space, they'll feel this vibration that kind of feels like jumping on a pogo stick. That's where the name comes from. While the astronauts are feeling that, it's causing a lot of problems for the engine, so we don't want that effect, he said. The most recent test was for the engine controller that will be used on the third engine of the second planned flight of the SLS, which is set to carry astronauts. The Deep Space SLS rocket will be fueled by 4 RS-25 engines firing simultaneously to generate 2 million pounds of thrust and, working with a pair of solid rocket boosters, will produce more than 8 million pounds of thrust. RS-25 engines for the initial SLS flights will be former Space Shuttle main engines, modified to provide the initial power needed by the larger SLS rocket. According to NASA, a key part of that modification is the new flight controller, which works as the RS-25 brain, helping the engine communicate with the SLS rocket and providing precision control of engine operation and internal health diagnostics. NASA is testing all RS-25 engines and flight controllers for SLS mission at Stennis Space Center. The initial SLS exploration mission 1 will serve as the first test flight for the new rocket, and will carry an uncrewed Orion spacecraft. The engines for this flight have already been tested at Stennis and are ready to be attached to the rocket's core stage being built at NASA's Michoud Assembly Center in New Orleans. The current engine tests are for controllers for Exploration Mission 2, the first flight that will transport astronauts on board Orion. As well as testing those engines, NASA is preparing the B-2 test stand at Stennis to test the entire SLS core stage with its 4 engines for EM-1. This green run test will require installing the flight core stage on the B-2 stand and firing all 4 RS-25 engines simultaneously, as in an actual launch. The RS-25 tests at Stennis are conducted by a team of NASA, Aerojet Rocketdyne and Syncom Space Services engineers. Aerojet Rocketdyne is the RS-25 primary contractor, and Syncom Space Services is the prime contractor for the Stennis Center's facilities and operations.